The lecture is about fluid mechanics. In this video lecture, we are going to briefly discuss about problems on viscosity with shaft and sleeve assembly. Problem number 3. A 15 centimeter diameter vertical cylinder rotates concentrically inside another cylinder of diameter 15.10 centimeter. Both cylinders are 25 centimeter high. The space between the cylinders is filled with a liquid whose viscosity is unknown. If a torque of 12 Newton meter is required to rotate the inner cylinder at 100 rpm, determine the viscosity of fluid. See, in this problem, they are given a torque value and they asked us to find the viscosity of the fluid. First, given. They are given the diameter of the shaft D as 15 centimeter. Therefore, D is equal to 15 into 10 to the power minus 2 meter. They are given your sleeve diameter ds as 15.10 into 10 to the power minus 2 meter. They are given the length of the cylinder L is equal to 25 centimeter. Therefore, your L is equal to 25 into 10 to the power minus 2 meter. Then they are given your torque T as 12 Newton meter. Last, they are given your speed N as 100 rpm. Solution. First, we are going to draw a shaft and sleeve assembly. Sleeve. In between your sleeve, we have your shaft. The diameter of the sleeve is ds. The diameter of the shaft is d. The distance between your sleeve and your shaft is dy. And F is being the force acting on your shaft and sleeve assembly. Now, we are going to calculate your thickness of your oil film. From the diagram, we know that dy is equal to ds minus d by 2. Substituting your ds value and d value, we get dy is equal to 0.05 into 10 to the power minus 2 meter. Next, in the problem, they have not given your velocity. Okay, therefore, we are going to calculate your velocity, where du is equal to pi dn divided by 60. Substituting your d value and n value, we get your du is equal to 0.78 meter per second. Next, we are going to calculate your force F, where torque T is equal to F into R. Torque T is being given on your problem and your radius of the shaft is being given on your problem. Substituting your torque value and your radius, we get your F is equal to 160 Newton. Next, we are going to calculate your shear stress, where tau is equal to F by A. Substituting your F value and your area A as pi dl. Substituting area A as pi dl, we get your tau is equal to 1358.12 Newton per meter square. Last step, we are going to calculate your viscosity of the oil, where tau is equal to mu into du by dy. We have calculated your tau value, du and dy value. Substituting your tau, du and dy value, we get your mu is equal to 0.870 Newton second per meter square. We know that 1 Newton second per meter square is equal to 10 poise. Therefore, mu is equal to 8.70 poise. Problem number 4. A hydraulic lift consists of a ram having diameter of 35 centimeter, which slides in an 35.015 centimeter diameter cylinder. The annular space between the ram and the cylinder is filled with an oil of kinematic viscosity of 280 centistokes and the specific gravity as 0.9. Find the viscous resistance experienced by the ram traveling at a rate of 15 meter per minute with 3 meter of ram engaged in the cylinder. See, In your previous problem and all, they are given your dynamic viscosity. Whereas over here, they are given your kinematic viscosity of your oil in centistokes. Okay. Then they are given your speed in meter per minute. So given they are given your diameter d as 35 centimeter. Therefore, d is equal to 35 into 10 to the power minus 2 meter. They are given a sleeve diameter ds as 35.015 centimeter. Therefore, ds is equal to 35.015 into 10 to the power minus 2 meter. Then they are given a kinematic viscosity as 280 centistoke. In order to convert into meter square per second, we are going to first converting your centistoke into stoke. That will be 280 into 10 to the power minus 2 stoke. That will be equal to 280 into 10 to the power minus 6 meter square per second. Next, they are given your specific gravity of oil as 0.9. Then they are given your speed in meter per minute. Therefore, your du is equal to 15 meter per minute. Therefore, in order to convert into meter per second divided by 60, therefore du is equal to 0.25 meter per second. Last, they are given your L as 3 meter. Solution. First, we are going to draw the diagram of shaft and sleeve assembly. Where sleeve, in between your sleeve, your shaft has been rotating. The diameter of the sleeve is ds, the diameter of the shaft is d, the distance between your shaft and the sleeve is dy, and there has been a force F acting on your shaft and sleeve assembly. First, we are going to find your thickness of your oil film, where dy is equal to ds minus d divided by 2. Substituting your ds and d value, we get your dy as 7.5 into 10 to the power minus 5 meter. Next, we are going to calculate your speed because they have not given your speed of the shaft. Therefore, velocity du is equal to pi dn divided by 60, where du is being given on a problem and diameter of the shaft is being available. Substituting it, we get your n is equal to 13.64 rpm. Next, we are going to calculate the dynamic viscosity of oil. In the problem, they are given a kinematic viscosity. We know that kinematic viscosity is equal to mu by rho. Substituting a kinematic viscosity and rho. See, rho has been not directly available on the problem. Instead of rho, they are given your specific gravity of your liquid. Multiplying your specific gravity of a liquid into density of your standard fluid, we get your density of your liquid. Therefore, substituting your kinematic viscosity and your mu divided by your specific gravity is 0.9, the density of your standard fluid, that is water, is 1000. Substituting it, we get mu is equal to 0.252 Newton second per meter square. Next, we are going to calculate the shear stress, where tau is equal to mu into du by dy. Now, mu we have been already calculated and your du by and dy has been available. Substituting your du, dy and mu value, we get tau is equal to 840 Newton per meter square. Next, we are going to calculate your shear stress, where shear stress tau is equal to F by A, where your A is equal to pi dl. Substituting your tau value, instead of your area, we are going to substitute as pi dl, where substituting your values, we get your F is equal to 2770.88 Newton. Next, we are going to calculate your torque, where torque T is equal to F into R. Substituting a F value and your R is nothing but your radius of the shaft. Substituting it, we get your T is equal to 484.90 Newton meter. Last step, we are going to calculate your resistance of motion. Your resistance of motion, we know that P is equal to 2 pi nt by 60. Substituting a n value and a t value, we get your power P is equal to 692.62 watts. Thank you.